Last class, we done a theory on the arithmetic sequence. Today we'll do theory on geometric sequence, and we'll do practice by yourself with James after the class. Geometric sequence is more important than arithmetic sequence because it has its own sequence and series of theory and questions and theories and that sort of things. But it also two very important applications. One is finance. Important because it comes in exam very often, but not that hard. It's recurring decimal. But the finance is a big topic in your exam. If you topic to be covered is geometric sequence, then that will be heavily assessed in 2 unit and 3 unit. 3 unit as a harder 2 unit, and 2 unit as it is. So geometric sequence, as most of you already know, the property is it is also a series of sequence of number or terms. Terms means could be polynomials or any kind of mathematical expression, but it starts with certain initial number or term, and then as it goes, each term we multiply a common number, a common ratio. Then that is a geometric sequence. So geometric usually means multiplication. So easiest way is we do say first term is A, the next term will be AR, and the following one will be AR square. That's the common practice. So if it keeps going in first, second, third, then nth term, which is a general term, what is the formula for nth term then? A, R, and minus 1, because it starts from 0. So remember, it's like it goes together with the formula in arithmetic sequence. In arithmetic sequence, it's adding it. Common difference added how many times? R minus 1. Geometric sequence, how many times multiplied? R minus 1. What is it?
Alice?
Alice?
Oh, I don't know.
Okay, so anyway, but the variation could be, don't just stick to this form. It could be any forms. Like the first one can start A over R cube. Then next one will be A over R2. The next one will be A over R and R. It could be anything. As long as it starts with something and multiplied by something, then that's geometric sequence. Also, in other way around, it is also possible. Same thing, isn't it? What are we doing? We are multiplying by 1 over r. So still geometric sequence. So there are many different things. And what about 1 x squared over little bit unusual one? Then what's next then? If we assuming this is geometric sequence. Like that. So what is it multiplied? X squared over tangent x. That's multiplied. So this is a geometric sequence too. Okay? So remember there are different ideas, but we usually write down in this way. But more proper sequence and series question, there will be more variety of things. Applications, we usually start from here.
Wait, you mean start from there?
That type of one. That type of different. They don't usually use like a very different
So
one.
we don't have to like make another equation from ourselves.
Yeah, in finance wise, usually we use straight from here. Then if you go to real real number. One thing is, and then what's next? Yeah, that's in this type. This could be also arithmetic geometric sequence because you're multiplying 1 over, multiplying root 2 minus 1, root 2 minus 1, root 2 minus 1. What about this? Oh my God. Doing it. Six. So that could be what series? This is an arithmetic sequence. Remember that.
Can't be geometry.
No, it can't be geometric. To get this, what do you have to multiply?
2.
2. Then from here to there,
Oh.
different. To get here, because that equals 2 log x, that's 4 log x, that's 6 log x. So by having the power increasing as arithmetic, actually it's not the power, it's just coefficient. So in the log, the typical, it's not hard, but typical trick in easy questions. The geometric sequence within the log, that gives arithmetic sequence. Okay, this is arithmetic sequence. So in general, what we have to remember, okay, general term for geometric sequence is A, R, to n minus 1. That's the general formula, all right? But again, I like to emphasize, A not necessary to be A, R not necessarily just R. It could be anything, any different form. That's more conceptual idea. Then what will be our next interest? More importantly, calculating the sum. So I think when you're doing the arithmetic sequence, when I introduced the sum formula, I gave you the episode of from famous Gauss, the person, episode. The 7-year-old developed the formula for arithmetic sequence. But for geometric sequence, from my memory, no one really stand out. So it's your turn now. You can make a history. So remember in arithmetic sequence, when you make up some formula, you're doing n a plus d, a plus 2d, blah blah, a plus m minus 1d. That's the sum. Then we made another sum in opposite direction. A plus m minus 1 d, ding 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 ding, and a plus d and a. Then you add it up. Then, as I told you, because they are linear increasing, they balanced out. Exactly the same term. That is a plus nd, 2a plus m minus d. And each term, that one then plus will be 2a plus m minus d. All the terms will be like that. So that means two times of sum will be 2a plus m minus 1 t. How many of them? N. So to calculate the Sn divided by 2, that is the formula. Similar idea comes out for geometric sequence. Let's say sum of the geometric sequence is a plus, in here a means the first term, r means the common ratio, and keeps going. And very often, because it's adding up to nth term. What is the nth term? A to m minus 1. Then would you like to do this again? If error, no, each term is totally different. They are different. So we can't do that. But we use this trick. Because each terms are it has a kind of common factor. So someone pointed that out. Okay, then what about if I times r on each side? Then it becomes, it will generate, the idea is, if we multiply r on each side, then the original one, then the new terms are very much similar, except the first and the last one, because that one will become ar, that one become ar square, that one become ar cube. So they are basically same. It's almost same, except what? Except the first term. The first term, they don't have that term, but this is from here, and that one becomes a to the power n. So each term have very much similar terms. So what can you do? Subtract them. So get rid of everything. The sum will be very simple. So subtract. A, gone. A minus, few chance left. This one. A, Rn. Now you have formula there. That is factorized. That's the formula for geometric sequence. So again, one thing you have to remember, when you use that formula, it will be safe. It will be safe if you memorize it is some pattern. What does it stand for? It's just n. Don't memorize it as n. It is n in this situation, but don't memorize as n. What will be the exact meaning of n? Number of terms you are adding. Add it. Okay, remember, that is number of terms added. So 1 minus r to the power number of terms to be added divided by 1 minus r. That's the formula. Okay? The reason I'm emphasizing is, if the situation is very awkward, mixed up, tends to make mistake. They don't know what to put it in. Then what's the answer? Number of terms. Number of terms. For example, simply you assume that we have half, 1, 2, 1/4, 4, 8. Now you like to add up. And just look, what is it? It's an arithmetic sequence? It's geometric sequence, isn't it? So okay, so you can use that one. So that is, what is the first term? 1/4 is the first term. 1 minus, what's the common ratio? 2, isn't it? We've been multiplying 2. 1 minus common ratio 2. So isn't it? Everything is very straightforward. The only question is how many terms there. In this case, you don't need to worry about. Just count. 1, 2, 3, 4, 5, 6. 6. That's what I'm saying. Okay, we'll do a little bit more. The situation you might be confused. Say we have something like that.
What's that 2 for?
We'll like to add it. Then can you see this is a geometric sequence? Yes. So we have to use it. What's the first term? 2 to the minus 10. And 1 minus, what's the common ratio?
2 to the power 3.
8, 2 to the power 3. And 1 minus 8. Then you have to find the number. What is the number? Those who just memorize as 1 minus r to the n, then confused. What is it? The common mistake is they put in n minus 1 or just n. But what's the meaning of this? Number of terms. So you have to count, find out how many terms there. Then how can you, if you're really not able to find the number, then you make it up. Minus 1, 2, keep going. How many would that be?
Wait, what are you?
Huh? How many terms there? If you can't make it up, then you have to actually count it. Next one is minus 1, next one is 2, 5. You can do that. Or what's the other way? The power is actually, what is it? Power itself is making arithmetic sequence. So think about the arithmetic sequence, start from there to here. To do what? To find how many terms are there, isn't it? So finding term itself becomes arithmetic sequence now. So consider this as an arithmetic sequence. And arithmetic sequence, what's the initial term? Minus 10 is A. And what's the common difference? Common difference is 3. We are adding 3. So the power, general formula for the power will be minus 10 plus n, which we like to know. Minus 1 times 3. This is the common formula. And we like to know how many terms are there. So what is the last term? That's 23. And 3n minus 13 equals, I made a big mistake, isn't it? It doesn't exist. I was trying to make it up. 23. Does it? It is? Does it exist? 3n equals 36. Yes, it works. 12. So it's a 12. So what do you do? For 12. I pick up the question, but end up with a little bit complicated. But important point is, what's this? Number of terms. Remember.
Sorry if this is a trivial question, but in textbooks, why do they separate this formula into r is greater than 1 and r is less than 1?
Okay. I'll tell you later. Yeah. Any questions so far? What's the answer? 1/3, isn't it? Then what about this? How do you calculate? Is it from? I'm starting to forgetting, but is it over 90? Is it? There is a certain formula, isn't it? No? Calculate. Use the calculator and see how it goes. 57 divided by 90. Is correct? No? What about this? No? This? No? Same. What is it?
57 or 99.
99?
Yeah.
99, yeah. So there is a certain pattern, isn't it? So in what case it becomes 90? That's different, yeah. When it is additional things, yeah. Okay, so now there is a certain formula when you do that, put 9, 9 and repeating terms, put 0, that's the formula there. But you can't use that anymore in your exam. You're never gonna use that formula in your exam for next 1 year. In this question, what do you have to do? You have to use geometric sequence. Or geometric sequence or you can use, sometimes they ask, in a way, remember the way that I derived the formula? Sometimes they ask it. So in that case, I'll show you in two different ways. Just using the formula. Next one is just for like by principle, the basic algebra. So say his name is X. Then you derive the formula. How did you do that? Our idea is this is an endless going out term. We like to get rid of it. How can you get rid of it? Easy. Multiply how many? 100. Then two terms comes out, but it has endless 77. So 57. 57. Then our idea is what? Subtract it, then whole term will go out. Subtract it. Then 99. This is where 99 comes from. Becomes all gone. Minus 99 minus 57. X equals 57, 99. Then what if we use the formula for geometric sequence? Geometric sequence. Then if you consider that as a geometric series means addition, then what is it like? It is that one plus 0.0057 plus 0.000057. So that means first term is 0.57. What's the common ratio? 100ths. Then how many terms? How many terms, Eric? Oh, how many terms, Simon? Simon already done it. Yeah, so how many terms are there? Infinite terms. So you put infinite. The formula will be Sn will be. So what was our formula? 1 minus r, which is 1 minus, what's r? 100th. A, 0.57. 1 minus 100th. What's the power? Esther, look at this.
N.
Power? What's this? 0. That's why.
What?
That's why they're using without this term. But we'll get to that again. So that becomes, you multiply 100 top and bottom, then becomes 57, 100 minus 1. 100 minus 1. Then it becomes that. Okay? In exam, in situation, they might ask in this way, or they might ask in this way. So this is quite easy one, so I'll give a really slightly different one. Then we move on to what about how can you do that? That's easy. Don't worry. It's just simple addition. Even your youngest brother can do it. So leave it alone and do this. The whole thing is not geometric sequence, but if you take that out, that is geometric sequence. Then simply, in this case, it's geometric sequence. A series with a equals 0.035. What's r? Because there are two terms, r is 1/100th. If it is three terms, like this, three terms repeating, then what will be the common ratio, 1,000th, because that's repeating. Because for your fun, let's have another one there. Six, 1,000. If you want to do the basic algebra, then you can separate and you can calculate. Say this is x, then x equals 0.0356356. Then what you have to multiply? You have to, that part have to come here, isn't it? To cancel out. So that must be up to there. So you have to multiply 1,000. 1,000x. Then that becomes 356, but you have 653, isn't it? Like that, correct? 1, 2, 3, yeah. So basic idea is that second repeating must be come up to here. Then subtract. Then becomes, you subtract from here to there, 999. X equals then 35.6, then x equals 35.699910. So that's algebra, if you want to do that in that way. And plus, and the whole answer is therefore 0.2 plus 3569990. Then I leave it on to you. I wouldn't calculate this. Then, do you get the same answer by using the formula? In this case, A is 0.0356. 1 minus, what's R? Thousands. Infinite. 1 minus 1,000. Then you get the same answer. Of course, this is 0.
You know how like you times it by 1,000? How do you know that you have to times it by 1,000?
Because you have to get rid of repeating three digits. So 3 digits are repeating. So they have to move by 3 digits. Otherwise, they can't be in the exact. Because these will have to come up here. Then, because that one and that one have to coincide to get 0 and they are subtracted. So 3 repeating, you have to move 3 digits. So you have to multiply 1,000. If 5 digits are repeating, then the 6th one have to come up 5 digits front. So you have to multiply 100,000. Otherwise, if they are not equal that way, it's not going to be 0. There will be some number left. Then you can calculate again. So idea is completely removing the tails. Then from our calculation, I'm sure you have noticed. Now the formula is this. In the case like recurring decimal, in the case if the terms are infinite, so that means infinite series, so adding endlessly, then if the limit, if you put it this way, there will be only 2 answers. What are the 2 answers? Maybe 3 answers. Case 1, 2, 3. What have you noticed when you do decimal? Because it really become really big, that part answer is very simple. Only 3 answers. 1, what is the answer? In like infinite decimal, the answer will be 0. Because it's infinite, if R is less than 1, it's always 0. So in this case, Rn equals 0. So in this case, what is the formula? 1 minus R. In what case does it happen? R is, absolute value of R is less than 1. Second, what's the other answer? 1, isn't it? So if it's 1,
I don't see how it's 1.
huh?
How is the other answer 1?
I mean, equals 1. If your R is 1, even if it's infinite, is 1. But in that case, what happens? Denominator is undefined anyway. Then what does that mean? In this case, the sequence will be like A, endless A. So what's the answer? Answer does not exist anyway. So answer does not exist. If it's minus 1, same. So in this case, so our idea is if R is smaller than 1, then by times, many times, it becomes 0. So it doesn't exist, gone. Then what about it's just 1? Just 1, what's the sequence like? Sequence like, what is it? A, isn't it? What's the answer? Does not exist. It's gonna be infinite anyway. So it doesn't count. What about minus 1? If R is minus 1, what is the sequence like? A, minus A, plus A, minus A, plus A. What's the answer? 0 or A. So we don't know. Anyway, undefined, isn't it? How do you know it's a 0 or A? It's a matter of whether infinite is even or odd. But there is no definition like that. So you don't know what the answer is. It's gone. So we don't usually count it. Then what about if R is bigger than 1? That means if R is bigger than 1, what happens? The sequence becomes increasing slowly. Maybe slowly or faster. Anyway, it's exploding eventually. So what's the answer? Doesn't exist. So those cases, answer does not exist. So in infinite sum of geometric sequence, only in infinite sequence, the answer is only 2 ways. Does not exist or exist, but the answer is A over 1 minus R. Okay, so therefore, in infinite geometric sequence, answer is 2. If it's less than 1, then answer is A over 1 minus R. Otherwise, answer is not exist. Can't calculate. It's too big, or we don't know which one to choose. It's A or 0, we don't know. But when you, this formula, you like it? So still one common mistake, but I'm sure in this class there will be no one who's making that kind of mistake. They don't remember this, they just see this. Can you imagine the situation? Oh, that geometrical sequence goes infinitely. Therefore, answer is A over 1 minus R. Can happen. Okay, you will see, or some of your friends will do it. But again, remember, in infinite geometric sequence, 2 answers, not 1. Infinite geometric sequence, answer exists only if the R is less than 1. Otherwise, does not exist. Another point, I'll emphasize a few times more. When you use that formula, again, like T formula, you know, when I introduce the T formula, what did I say? There is no T formula, just substitution. What is it? Our thinking, how the T formula start? See, if angle is not 180, isn't it? If angle is not 180, then blah, 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 blah. That's our formula. So never gonna forget. Never gonna make a mistake. That's same. We don't have that formula. We don't have this formula. What formula do we have? It's like when you use that one, always comment S R is less than 1. Sn equals A over 1 minus. Okay? If you miss that term, you gotta mark off. So if I summarize it, for those who wants to prefer to summarize, the sum formula for geometric sequence, there are 3 cases, isn't it? 3 cases. 1, 2, 3. A 1 minus R. Yes. 2. The 2 cases. If then not exists. There are 3 formulas. So your questions result sorted out. You asking why there are 2 formulas. That's the scenario.
Actually, it was on that first one.
Oh.
Like some books say R and minus 1, R
Okay,
minus 1.
we'll see. Once I can use it, I sometimes use that formula or sometimes use this formula. What's the difference? They're saying, Eric, in what situation I use that one, in what situation I use this one. That's right. If your R is bigger than 1, if you're using that one, you end up with a minus. Don't like it. So once R is bigger than 1, then use that one. The calculation is clear. Is that your answer? Was that your question? Yes, they're exactly the same. But which one to use is your option. So as soon as I start, I think is R is bigger than 1, less than 1. Then bigger than 1, I go with that one. Then when you do finance, which one is most likely to be used? So that means the finance is like compounded interest. We are talking about compound interest, geometric sequence. So in geometric sequence, what will be the common ratio? Do you remember compound interest formula from year 3? Whose mom is, hard? Sometimes R is here, sometimes N is here, sometimes N is here. This is simple interest. This is compound interest. What does it look like? What is geometric sequence? It's not A, it's P, isn't it? Usually. So in finance, remember, what is the common ratio? Usually, most of 99% case, 1 plus R. What's R? Interest rate. So usually, 1 plus R is big. So in that case, we usually use that formula.
I don't get that.
This one? Don't worry, we'll get back to it.
So what was the common ratio?
If you see this one, common ratio 1 plus R. It's because you're continuously multiplying 1 plus R. So it's bigger than 1.
So why does it help you to use that?
Huh?
I think it's very
So far, everything's clear? John. If you, in our class, if someone's like a little bit sleepy, I don't mind stand up when stretch it. I don't mind. Do it. Who is the one who usually sleepy? Sometimes you? Esther? I never see you.
I was sleepy.
What did you do last night? Went to beach. Beach? Okay, so once know those formulas, there's another common questions happening in geometric sequence. So the question is about this. They are asking, for example, let's do simple one. Who should I ask? Simon. Don't open love letter. Open in toilet. Simon. Do you think this series will converge?
What's this conversion?
Converge means, yeah. Let's have a end up with a certain answer. End up with a certain number. What's the opposite? Diverge. Diverge means explode.
When you say it comes to a certain answer, do you mean like a limiting sum?
Limiting sum. Total sum. Does it happen in your school textbook? That's proper mathematical word. So let's say limiting sum. So Simon, if you add up all those things, do you have an answer for it?
How do you know that?
That's what I'm asking him. Huh? But still, you can explain in what case then it can have an answer, in what case it can't have an answer.
Well, I think
It keeps getting smaller.
Keeps getting smaller. That's a good idea. One thing is, Simon's IQ is very good. I always noticed that. But he does not really put into practice. So that's very good idea. I mean, that's the right answer. We talking about this. This is more mathematical idea. What does that mean? The sequence is getting smaller. In any geometric sequence, if it's getting smaller, then it always has an answer. That's the same. R is less than 1, it's gonna be smaller, decreasing. But decreasing in what way? Geometrical way. For example, what do you think? Will it have an answer or not? It's decreasing. If it keeps going, do you think it has a converge or diverge? It goes to infinite. Even though it's decreasing, it's not decreasing in geometrical way. You can prove it. How can you prove it? One idea is if like that. 1 cut into certain, so you're making 1. What is bigger than 1? If you add up to here, is it bigger than 1? No? What's the sum of this? It's bigger than 1 here, isn't it? And you can cut somewhere bigger than 1. So you can have a certain, collecting certain number of terms, you can make always bigger than 1 term. But it goes infinitely. So
I don't get the cutting method.
don't worry, don't take it seriously. Just I'm giving you an idea. So in that way, it always you have a certain, if you collect them, now 3, next one 7, next one 100, 200, you can always collect a certain term which gives bigger than 1. And it keeps going. So that means it's going. But this one decreasing with geometrical sequence, isn't it? So what's the answer? This is 2. This is 1. Try to find 1. You can make 1. Why? Why you can make 1? See? It covers half. We need a half. But next one only takes half of the remainder. Then this one takes the half of remainder. And half of remainder keeps going. Half of remainder, half of remainder. Never gonna make up 1. But that's the end of 2.
So what if we start with 2? Then will it be?
Then 4.
What if we start with 3? 6?
6. Do you get the idea? So geometrical sequence, what it does is, if the common ratio is half, then what it does is, it's taking half of the rest. Half of them. If the common ratio is 1/3, what it does is, taking, next term takes 1/3 of the leftover. 1/3 of leftover. So never reach a certain point.
So just say whatever the first term is the limiting sum double that, or does it depend on the ratio?
The ratio, of course. That's what I'm saying. If ratio is 1/3, the next term takes 1/3 of the total sum, leftover.
So if it was a third, what would it be then?
Then what if you 1/3, maybe think about it. 그러면 1 minus 1/3, and 3 on 2, 1.5. So first one takes 1, the next one, so we know the total answer is 1.5. What it does in each term takes 2/3 of the leftover. So this one takes 2/3 of this. Then we left it half, isn't it? Half left. He take 1, you half left. This one takes certain portion of that one. Then never get to that one. So they are doing like this. This says 1 and 1.5. 2/3, take 2/3. So 1 takes 2/3 of it. Next term take 2/3 of the left. 1/3. And the third term takes again 2/3 of the left. Next one, 2/3 of it. So in that mechanism, they'll never reach that end. So continuously cutting into that limit, within the limit. See? That's the property of geometrical sequence. Get the idea?
Yeah.
Yeah. That's the geometrical sequence idea. This one's different. They goes over continuously. So, saying that, so Simon's idea, looking at that as just decreasing sequence, that's correct, as long as it's geometric sequence. So that's good idea. But back to this one. So if it is decreasing geometric sequence, it will have a definitely limiting sum. But to be decreasing, what is the mathematical condition?
You wrote it on the board.
Common ratio is less than 1. So common rate, it must be decreasing geometrical sequence. In mathematical term, common ratio must be less than 1. So in your question, in your exam, common question, you will definitely get one question in term exam. What they ask, they give a geometric sequence. They ask, this is an infinite geometric sequence, or whatever. They may not comment on it. You have to find out this is a geometric sequence, but of course it is obvious. Then they find x value, find x for the series to have a limiting sum exist. Then what does that mean? Find x for this. That's what they're asking. So for that series, which is a geometric sequence to have a limiting sum, that must be this. So what's the ratio? Tangent square. So tangent square must be less than 1. Of course, because it's square, it can't be less than, it must be something like this. That means tangent of x is minus 1, plus 1, 1, isn't it? Then what's the answer? Between plus minus pi on 4, plus minus 45 degrees.
Wait, so tan x is between 1 and 1?
Well, minus 1. So x must be 45. 45. If you just comparing first quadrant, second quadrant. Remember, you will get that question. Find the restrictions of letter to have a limiting sum. Why is you smiling so much?
This is really fun.
last few days,
So can the limiting sum be negative? Because it's a
of
term.
course. How can the limiting sum can be negative?
If the terms are
If the first term is negative and the common ratio is positive, it's got to be negative. Even it is possible. First term is negative, but common ratio is negative, still can have one. Like what? Say -1, next one is half, next one is -quarter. So common ratio is -half, isn't it? Then of course, if it's all positive, what was the answer? 2, wasn't it? So 1 and take half of it, then make up 2. But in this case, answer will be less than 2, isn't it? Because they are canceling each other. Fighting, domestic violence.
so now it's 2 minus 2.
Oh, no.
What is it now?
Maybe minus something, isn't it? The minus slightly wins, negative slightly wins. Then what's the formula? Then when you use the formula, remember what you have to start with.
If R is less than 1.
S, not if. Obvious in this case. As R is -1, answer is -1 over 1 minus, what's the ratio? -half. So, -1 over, what's 1? 3 on 2, so -2 on 3.
Are there any special limiting sums?
Special limiting sum.
Like trick ones, like asking exams?
Yeah, that's what I gave you.
That one?
The tangent one. Yeah, limiting sum question is almost always finding the boundary for certain letter. I'm trying to thinking of is there anything I'm missing in terms of idea. One interesting one. Do you remember that formula? Especially for foreign students. Remember that? Because you are not foreign student.
But you said especially for exams.
Do you remember that? If you don't remember that, probably you remember this. Do you remember that? If you don't remember that, you must remember that. Yeah, remember now.
Do we need to know this?
No. It's very similar to what? This is what? Geometric sequence. R minus 1, R to the power of n minus 1. So that formula, you're all right. So look at this. If you consider you like to find the sum of this. This is geometric sequence. Yeah? What's the first term? 1. So how many terms? Limit? If it's not limit,
No limit.
if it's not limit, like the indefinite, the answer is always 1. What is it? A times. In this case, let's do that one. What's the common ratio? X. Isn't it? Common ratio is X minus 1. How many terms are there?
Infinite. I mean, n minus 1.
Indefinite. Definite.
N.
How many terms? N. 0 to n minus 1. N. What's term? 1. So now you can prove the factorization. So if you go this way, then xm to the minus 1 will be x minus 1, xm minus 1. Okay? So you can prove that formula by using geometric sequence.
So they might answer in a 3-unit paper, right?
Don't worry in the 0 unit. But maybe they can be in a similar question, can come up. But just reminding them for complex number. Not interesting, Karen? So we'll do few examples.
Are we going to do sequence and series next week as well? Well, for a few weeks.
No, we have to run very fast. We're gonna do finance.
Do we have
Maybe
a lesson
tomorrow.
tomorrow?
Yes.
Because you know the email, it was really confusing. It said from 4:30 to 10, students will have tutorial sessions from Wednesday to Friday. And then on
Oh,
Thursday...
don't worry. Tomorrow will be exactly the same as today. Then next Friday will be same as the last term, but slightly different order. And in this term, year 12 you'll start first with me.
We have a class tomorrow.
Yes.
Oh, but
He's going camping
what about asking question session then?
after this.
But that's our tutorial. What about the question, like, you know, we used to have Thursdays where we come after school and ask questions?
Yes, that will be on Thursday, but not today.
So starting from next Thursday, we'll have this.
I'm confused. You have to check.
'Cause
From
the
next week.
exams are really
Yeah, from next week. Yeah, sure. Yeah, there is one. Oh, me? I'll check. Check timetable. I mean,
The
already.
timetable's different.
Come tomorrow, then it'll be clear. Call this number. She is the expert. I'm not. I only know when I should come. Whoever called this number? Emma called? Karen called? No?
But when I call, it's always closed. Sometimes. Like,
Yeah.
sometimes I call to check if I have a lesson.
Call this number. Don't hesitate. Don't send me email. It's late. Sometimes I don't watch. And my habit, whenever I answer the email, many times, whenever, for example, Karen send me an email, then whenever I think about Karen, there is something related to Karen. Some thought related to Karen come up, then I have to start writing something.
What?
So don't send me email. Call this number. Something trigger me, do something. Don't trigger me. Who never called this number? Rosie never called? Please call.
What's it called about?
Any question?
Like math?
Yes, you can. Then I'm sure she'll answer you as far as she knows.
So is it like
But not much.
24/7? Okay. Who's she?
She.
Oh, the helper person.
Oh, it's confusing. Where is? Ah, here it is. See, the old man, only about 3 weeks away, forgot even know where to click to enlarge the picture. So don't get old. Have a look at question 33. Hands up. Find the sum of the series for what range of values of A has this infinite series or sum. What is it? What does it say? So I'll give you half minute to do it. During that time, I'll talk about one thing. Last few days, it took for me about last few days to sort out my 3 years lecture in the computer in sorting as a library.
So it's good now.
Yes, and everything sorted as a theory, practice, and methodologies. So I'm gonna open into the computer, so you will see whole library on spot. And that will be more useful as trials comes up. So everything reviewed, all the past papers. So 33. Find the sum of the threes. She's missing. Where have you been? Secret place. So in this one, what type of series is it?
Infinite.
Geometric series. Geometric and infinite. And that's geometric series with A equals 1. What's the common ratio? It is 1 over A plus 1. Find the sum of the series. Can we? No. Only 1 over A plus 1 is less than 1. Then the answer will be 1 over 1 minus R, which is so when you answer, you have to comment precisely. That's the case, the answer will be this. And otherwise, there will be no answer. Otherwise, sum does not exist. Not exist. See? You have to answer clearly. They ask the sum. But because it's an infinite series, there are two different cases. Exist or not exist. So in this case, exist. But in this case, then what's the A? Then A plus 1, A. That's the answer. Then you have to solve it. It's not that easy, isn't it? It's not that easy. It's not that easy. Absolute value. We are not very happy with the absolute value. So who's good at absolute value? Who is the absolute? There's a newcomer there. You look different. Is it because of the glass or haircut? You look more mature. Are you taller than before?
Yeah, cool. Really? Yeah, like we were doing it. I'm 176 now.
Really? Okay, then go for this. It's not easy, isn't it? It looks simple, but it headache. Go. Tall girl. Tall girl. I will say tall girl. Is it different pronunciation or same?
Same pronunciation.
Same pronunciation.
But actually, tall.
That's tall, isn't it? Tall. Anyway, doesn't matter. Quick. What's the next? What do you do? Oh, you did 4 unit. Locus. If that happens, how we do it?
Locus?
I don't know. When I say in the case of 4 unit, then just shut your ears. Doesn't matter. That one to be less than 1. So in back to 3 unit. That is same as this, isn't it? Absolute value we can separate it.
What's this?
Absolute value we can separate. Sure? Yes.
Yes.
then this is 1. Then this one to be less than 1, this one to be greater than 1, isn't it? Greater than 1. If the denominator is greater than 1, then that's easy. This one to be greater than 1, what do you have to do? Greater than 1 or less than minus 1.
Why does the denominator need to be greater than 1?
Then that means it's bigger. Where are you going? Tolgo? Okay, and then greater than 0 or less than minus 2.
So like you wouldn't.
Absolute value is always a headache, you know?
But what if the top was A?
Towards A, then headache, a lot of headache. Then you can't separate. You can separate it, but it doesn't really work. So if it's A over A plus 1, then I rather go this way. Correct? Yeah? And sketch, graph sketch and cut.
That's so smart.
If you draw, how would you draw? So not proper fraction, isn't it? Simplify first. Then the graph will become. Yeah, in extended question, it's very possible question. They ask this one first, maybe. This graph, draw the graph there, and ask geometric sequence, and therefore find the.
Is that a geometric sequence?
I mean, doing the geometry sequence, the one. See? So they can mix it up in this way. In this case, then, we like to know, then what's the graph like? One there, so one there is negative, so graph will be like this. And then we like to be this between minus 1 and 1. So what is the minus 1 is here, so answer is around there. So we have to find out that number from there to that number. So that area is where the limiting sum exists. Anyway, that's a little bit further away. So this is quite a likely question. So to solve sequences, just knowing sequences is not enough. Now you're starting to have to mix up all the different things. What is it? Let's do 30 and 1 over. That's 29 and 30. Then you have a joke break.
Doesn't look like a geometric. What happens if we can't find
This one, M is unknown. Depending on M, it could be a geometric sequence or nothing, or arithmetic sequence. So, in this case, if we have like this one, this is obviously geometric sequence, isn't it? That means regardless of M's value, it's always geometric sequence. Regardless of M. But in this case, depending on M's value, it could be geometric sequence, but not in general. Make sense? Yeah. So that's what they're asking. Success in terms of geometric sequence, find the value of M. So, back to the arithmetic sequence. If three numbers forms of arithmetic sequence, then what relationship should they have? Yeah, they have to form what kind of relationship? Arithmetic mean, which means sum of the other, twice of the middle will be sum of the other. That's the arithmetic sequence, isn't it? So A, B, C forms arithmetic sequence, then that must be average of this. So A plus C divided by 2 must be B. That means A plus C equals 2B. Because again, arithmetic sequence just balanced, like that, linear. So if you decrease by 1, increase by 1. So the middle one is always arithmetic, the average, isn't it? So remember, when three numbers are making arithmetic sequence, middle number is the average of the other two. Similar situation happens in geometric sequence. In geometric sequence, if the three numbers forms the arithmetic geometric sequence, then what's the relationship?
Is it common ratio?
Huh? Yes. Multiplication of A and C will be square of this.
What? Oh.
Because you, to get there, if they are geometric sequence, to get there, you divide by something, then you multiply by something. So this is divided by 2, multiply by 2. So if you multiply, then it's middle, isn't it? So for like this. At the middle, to get there, you divide. To get there, you multiply, isn't it? So if you multiply these two, the factor 1. Okay? So just take this picture, or even in this picture, square of this is same as multiply product of these two. So if you don't get those ideas, don't worry. What you remember is, if three numbers making a geometric sequence, square of middle will be product of other two. Arithmetic sequence, middle is average of the other two. But if you go a little bit further, why? Because of that relationship. First one is divided by something from the middle. Third one is multiplied by something from the middle. So if they multiply, the dividing and multiplication, they go on and end up with just middle term.
Her way was easier.
Huh?
She said a really easy way.
Yeah. What was it?
She said B on A equals C on B.
Yes. Yeah, something like. Okay, same thing. So when you do arithmetic sequence, what's another condition? The difference are same, isn't it? Difference are same. That's another idea. And if A, B, C, if they are geometric sequence, the ratio are same. B on A is used. So B on A equals C on B. Because they are in the same ratio, then becomes AC equals B squared. So whenever in those cases, so there's a specific number for that. So if product of two number is a square of a certain number, other number, then B is called as geometric mean of AC. Same thing. Sum of the two number is twice of other number, then B is called arithmetic mean of AC. So arithmetic mean is the average you are usually talking about. So remember, arithmetic mean is the middle term of the arithmetic sequence. Geometric mean is middle term of geometric sequence of three numbers. So A forms a geometric sequence. So what's the condition? That square must be that times that. So 2m plus 4 square must be 5m minus 2 times 2m minus 8. Should I do it?
Yes.
I'll leave it for you. You can do it.
Oh, I thought it was another trick, like it makes sense.
So there's one terminology, the mean. Estimated mean, geometric mean. There are many different means. Makes sense, isn't it? If this is geometric mean, makes sense, isn't it? Square root of two product. Oh, it's kind of average. Half of the sum. Oh, this is kind of average. So all makes sense. There's another mean, harmonic means.
Shouldn't it be plus
This is
or
how-
minus for A and C?
No.
Why?
from definition, B on A equals C on B, isn't it? That's definition. There's no way to put on plus minus. That's the exact definition. The same ratio.
Turn the air from down. Sorry.
Turn up, you mean make it cooler or hotter?
Warmer.
Warmer.
Oh, really? What's the harmonic motion?
That. A harmonic motion.
I mean,
They're moving harmonically. Harmonious. Harmony. There's one thing, isn't it? From Miss Beck.
Uzbekistan.
Miss Beck. You know? Jiang Beck. Huh?
Is she old?
She's about 30? Only 30?
I don't get that, what that means. B equals 2AB on A plus B.
There's something else. Don't worry.
Do I need to know it?
No, you don't know.
You need to.
You must not know. Making more confused. Well, there's another question over there. And 30. The sum of the first 8 terms of the sequence is 17 times the sum of the four terms. Find the common ratio. Wow. So, then, what's the sum of the first 8 terms? Say first term is A, common ratio is R. Then R, that is number of terms, isn't it? We are talking about 8 terms. That's sum of first 8 terms and first 4 terms. This is the first 4 terms, isn't it? What's the relationship? He or she is bigger 17 times. Then easy. Gone. It can be factorized with this. So that is R4 minus 1, R4 plus 1 equals 17, R4 minus 1. Gone. R4 equals 16. R equals plus minus 2.
Did you just tell us which?
Or if you really want, you can do this.
Before, you know how like B squared equals AC? How come you rejected B equals minus root AC? I still didn't get that. Oh, you told us this, and then you said another way of saying it is B equals root AC, but you rejected minus.
Okay. Let's put it this way. Again, and the origin, from the definition, the geometric mean start. What Emma says is really the basic property, isn't it? To be geometric sequence, the ratio must be same. So A, B, C. This is a real starting point. That's the purely 100 pure property. So this is number 1. Then so after that you end up it equals AC. Yeah, BC, and then you do. That's algebra. May not be reflect a pure property. So, but this is 100% pure. There's no room for him to get here. So we reject it. Algebraically correct, but considering the nature. Same thing, when you do equation for fraction, you check back if the answer makes the denominator 0. So even though it's algebraically correct, because it does not go with the original situation, it doesn't accept it. It's the same thing. That's the definition. Oh, we finished the lesson. So we'll have about 5 minutes or 10 minutes, 5 to 10 minute break.
Our tutorial starts at 6:30.
Is it? Because you are having break.
But you just said, so for 30 minutes break and then we do it.
Yeah, that's right. You do some work, then start to ask. Otherwise, tutor come and doing nothing.
You know the tutorial? The helper outside said that when the tutor comes, you don't ask your own questions, you go through the lesson. But can I ask my question?